Hey folks, Mr. Dell here. We are looking at a problem where we've got to find the area of an equilateral triangle given its side length. So this is coming from CPM's uh, Integrated Math 2. Oops, got ahead of myself there. Integrated Math 2, and this is section 8.2.1. Number 8-31. So it says calculate the area of an equilateral triangle. So I have an equilateral triangle. What is an equilateral triangle? It's a triangle with all equal sides. And it says that with a side length of 20.0 or just 20 millimeters. Draw a diagram, show all your work. So again, an equilateral triangle is a triangle with equal side lengths. So if it says it has a side length of 20, then that means all three sides are 20. That's an equilateral triangle. The other nice thing about an equilateral triangle, I know, is one of the properties are that all the angles are equal, right? Each of these angle measurements are equal. And we know that a triangle has 180 degrees total. All angles add up to be 180 degrees. So if I take and divide 180 divided by 3, I get 60. So that tells me that each of these angles are 60 degrees, right? So I can write that down. So there's some information I'm going to have because I need to find the area, right? To find the area of a triangle, right? Area of any triangle is always, so area of any triangle is always the base times the height and then half, so divide by 2. Because a triangle really is half of a rectangle. Rectangles would be base times height. So a triangle would be half of that. Half of a rectangle is a triangle. So to figure this out, I've got a base. I just need my height. Remember the height and the base. So the height and the base always meet at a 90-degree angle. So the height and the base always meet at a 90-degree angle. So I don't have a 90, but I can draw one in, right? I can actually draw in this height at 90 degrees. Well, what we've got is when you do that on an equilateral triangle, it is a bisector. It's not only does it bisect the side lengths, because that's what happens when you draw that. It's the this regular shape. You draw that height, it bisects it. So now that tells me that each of these sides are 10 on the base, and then it also gives me it bisects the angle. So no longer do I need to see the whole thing as 60. Now I can say this angle is 30 and that angle is 30, right? So yes, the whole angle is 60, but then it bisects it. So what we've got here is we've got a 30, 60, 90 triangle, right? So we know when you have a 30, 60, 90 triangle, there's some special relationships. Here's the special relationships. The special relationships is if I know my 30 and or my 90, if I know the hypotenuse, right? Let me draw a 30, 60, 90 so you can see what I'm saying here. So that'll be a 30, 60, 90. So the relationship of the 30, 60, 90 is this, is if I know the side opposite the 30, call that x, then the side opposite the 90, the hypotenuse is twice it, 2 times x. And then if I also know this opposite of the 30, to find the opposite of the 60, this side here, I multiply this side by the square root of 3. So that's the relationship that it has, these ratios. So basically, whether you go between these two sides, it's either you're going to multiply by the square root of 3 or you're going to divide by the square root of 3, depending upon are you getting to the bigger or smaller side, right? Smaller side to the bigger side, multiply by square root of 3. Bigger side to the smaller side, divide by the square root of 3. And then to go from this side opposite to the 30 and the hypotenuse, you either multiply by 2 or you divide by 2. So that's the options, right? Multiply by 2 if you're getting bigger, divide by 2 if you're getting smaller, right? So here's what we've got. If I look at I need to figure out my height, right? That height is opposite the 60. And I know my opposite of the 30. So if I know the opposite of 30, remember what do I do? To find the opposite of 60, you multiply by the square root of 3. So this height now is 10 times the square root of 3. So the area, here we go, the area for this triangle would be the base, which I know this whole, they got to do the whole triangle, right? So that's the whole base is 20 times the height is 10 square root of 3, and then all of that divided by 2. So that's going to be my area, which let's clean up. That I would divide, and I would actually have 100 square root of 3, right? Because I could divide the 2 into the 20, get 10. 10 times 10 makes 100. So 100 square root of 3, I can leave my answer in square root form and just say 100 square root of 3 millimeters squared, right? I could, in my calculator, if you really wanted to get the estimated answer, you could take and find that square root of 3. Let's see, let's do that. So 3, the square root of 3, and then multiply that by 100. So we could say the answer as well is approximately, so I could say the area is approximately 173 point, let's round up on the hundreds place, 21 millimeters squared. So I can also have an approximate answer. So either one of these, the approximate or the exact answer, is what we have. Okay, there we go.